My scenario is that Gerald, a dog in Dogtown, wants to find out how many of the other Dogtown dogs believe there should be a law stating that no cats can live in the same house that a dog lives in. Gerald sent out direct messages to all of his Dogtown friends on Barker, Twitter for Dogs, asking if they agree. 307 dogs responded to Gerald, and 214 agree with his proposed law. In this case, the sample is the 307 dogs in Dogtown, and the statistic is 214 out of the 307, which is 69% of the dogs, believe that no cat should be allowed to live in the same house that a dog lives in. The parameter is the percentage of all dogs in Dogtown that agree with Gerald's proposed law. When finding the 80% confidence interval, you find that it's 69% plus or minus 3%, and the range is 66 to 73%. When doing the 95% confidence interval, you find that it's 69% plus or minus 5%, which is 64 to 75% in the range. The 80% confidence interval shows that the range is from 66 to 73%, so this means that 80% of the time the parameter, or the percentage of dogs in Dogtown that believe that no cat should be allowed to live in the same house that a dog lives in, will lie in between 66% and 73%. In more simple terms, if we took 100 samples, then 80 of them would have the parameter in between 66 and 73%. The 95% confidence interval shows that the range is from 64% to 75%. So this means that 95% of the time the parameter, which is the percentage of dogs in Dogtown that believe no cat should be allowed to live in the same house as a dog, will lie in between 64% and 75%. And out of 100 samples, that means 95 of them would have the parameter in between 64 and 75%. The pro for the 95% confidence interval is that it is larger than the 80% confidence interval by 4% overall. The con for the 95% confidence interval is that it is less accurate than the 80% confidence interval when finding the true parameter.